Hello, and welcome to the CCNA Routing and Switching course offered by simplilearn. In the previous lesson, we focused on layers 7, 3, and 4 of the OSI model. In this lesson, we will discuss IPv4 addressing and subnetting. Let us begin with the objectives of this lesson in the next slide. By the end of this lesson, you will be able to discuss IP addresses, convert binary numbers to decimals, discuss classes, create subnets. Let us begin with an introduction to IPv4 addressing. An IPv4 address, hereafter called an IP address, is a 32-bit numeric identifier assigned to each device on an IP network. It is assigned in software and has no relation to the underlying hardware. The format is dotted decimal. It consists of 4 numbers separated by periods, dots. For example, 192.164.2.1 is a valid IPv4 address. There are 3 major types of IPv4 addresses. The first is unicast, where the packet is sent to only one device. The second type is multicast, where the packet is sent to many devices. The last type is broadcast, where the packet is sent to all devices in a network or subnet. For example, the broadcast address for the network 192.168.1.0/24 is 192.168.1.255. IPv4 addresses can also split into public and private addresses. Public addresses are those that can be used over the Internet. Private addresses are used only within a local area network, LAN. Let us find out more about private addresses in the next slide. Private addresses are also called Request for Comments RFC 1918 addresses because it is the name of the standards document that defines them. They can only be used within a private network and cannot be routed through the Internet. Therefore, they are also called unroutable addresses. The significance of private addresses is that by using them, the organization needs fewer routable addresses. Public addresses cost money. Devices with private addresses can still access the Internet if Network Address Translation, NAT, is implemented. NAT lets a LAN device borrow a public address when it needs to access the Internet. Next, let us look at binary numbers and how to convert them to decimal. The table on the slide highlights what it means when a 1 is in various digits of the number. For example, if a 1 is in the 6th digit from the right, this represents 2 to the 5th power, or 32.